6.2b, law of cosines. Again, you don't have to memorize them. You just need to know how to use them. All right, here we go. Let's put it into practice. I need a reader. Thank you so much. Kendall's going to read for me.
A ship travels 60 miles due east, then adjusts its course northward, as shown in figure 6.14. After traveling 80 miles in that direction, the ship is 139 miles from its point of departure. Describe the bearing from point B to point C.
All right, fantastic. So basically, we need to solve for this angle right there. We need to solve for that angle right there. Now, can I use law of sines? No, I don't. I can't use law of sines because I don't have a corresponding angle with the corresponding side. So what must I use? Law of cosines. So I'd have cosine of B is equal to what? 60 squared plus 80 squared minus 139 squared, all over 2 times 60 times 80. And before I put that in a calculator, what would I do? I arc cosine both sides. All right, I arc cosine both sides. Tell us what we won.
I got 166.15.
Love it. All right. Love it. All right, that's what I'm going to ask for on the test. But that's not truly what's being asked for. It asks to describe the bearing from point B to point C. I'm not going to ask for a true bearing on the test because I don't think we need it. However, which way did this go? North, and it went east. All right. So I actually need to figure out this angle right here. So it went north, but then something east. Well, what do I have to do to get this angle right there? What do I have to do from that angle? Subtract 90 degrees. So when I subtract 90 degrees from 166.15 degrees, that would be north, what? 76.15 degrees east. That is the true bearing of it. All right. Go for it, Angela. I think you like him. Go. Whoa. You forgot to read this part.
C, 100 BC.
A long time ago. All right.
And inventor. His works describe how to find the areas of triangles, quadrilaterals, regular polygons having set 3 to 12 sides, and circles as well as the surface areas and volumes of 3-dimensional objects.
All right, fantastic. So this is how you find Heron's formula. So area, when we have all 3 sides of a triangle, denoted by A, B, and C, the area of a triangle is given by square root S times the quantity S minus A times the quantity S minus B times the quantity S minus C, where this arbitrary number S is all 3 sides added up divided by 2. It's not a pure average, okay? An average would be divided by 3. Okay, so it's not an average of them. It's not a mean. It's an arbitrary number that Heron came up with a long, long time ago. All right. So now I need to find the area of a triangle given side lengths of 43, 53, and 72. Well, before I use anything, I'm given 3 sides. So I need to find what? S. So how do we find S? We add them all together, and then we divide by 2. And so what do I end up getting for S? I get an arbitrary number of 84. All right. So now I can use Heron's formula. So I get area is equal to square root of 84 times, what is the 84? The S minus A. 41 times, what is S minus B? 84 minus 53 is 31. And then what is the S minus C? 12. All right. What are my units?
Meters squared.
Meters squared. Why is it squared? Because it's two-dimensional. Good. All right. Now, no, you've known this first one for a long, long time. So area is 1/2 base times height. Remember that guy from like forever? All right. We also learned area of an oblique triangle is 1/2 BC sine A. But that angle has to be what? In between, or mathematically we call it included. It has to be an included angle in order to use oblique triangle area, or law of sines, some people call it. And then Heron's formula, when do you use this one? When you have all three sides. So if you have an included angle, use the area of an oblique triangle, or law of sines. If you have all three sides, use Heron's formula. However, how do you find S? You add up all the sides and then what? Divide by 2. All right. Worksheet 6.2b. Worksheet 6.2b.